In this lesson, we are going to learn how to move between characters and numerical codes. Computers represent characters using numbers. For example, the character A has the numerical code 65, B has the code 66, C has the code 67, and D has the code 68. To convert a character into its numerical code, we can use the ORD function. For example, ORD A returns 65. We can also move in the opposite direction. The CHR function converts a numerical code back into a character. For example, CHR65 returns the character A. So remember, ORD converts a character into a code, and CHR converts a code back into a character. These two functions allow our programs to easily move between text and numerical character codes. Now let's look at the ORD function. The ORD function converts a character into its numerical character code. For example, here we have the lowercase character circa. When we pass C into the ORD function, the computer converts it into its denary character code. The result is 99, so we can write this as C ORD 99. Remember, ORD takes a character as input and returns a number as output, so ORD C returns 99. Let's look at a few more examples of the ORD function. Remember, ORD takes a character and returns its decimal character code. For example, ORD A returns 65, ORD B returns 66, and ORD C returns 67. Lowercase letters have different codes. For example, ORD A returns 97, and ORD C returns 99. So remember, every character has its own numerical code, and we can use the ORD function to find that code in our program. Now let's look at the CHR function. The CHR function works in the opposite direction to ORD. It takes a numerical character code and converts it into the corresponding character. For example, we have the denary code 100. When we use CHR 100, the result is the lowercase character D. So we can think of it like this: 100 CHR D. Remember, CHR takes a number as input and returns the corresponding character as output. Now we can see how ORD and CHR work together. These two functions perform opposite operations. The ORD function converts a character into a numerical code. For example, the character A becomes 65, so ORD A returns 65. The CHR function does the reverse. It takes the numerical code 65 and converts it back into the character A, so CHR 65 returns A. Remember this simple rule: ORD, character to code; CHR, code to character. They allow us to move easily between characters and their numerical codes. Now let's see how we can convert an entire word into character codes. Our example word is cat. We process the word one character at a time. First, we take the letter C. Using ORD, C, we get 67. Next, we take the letter A. ORD A gives us 65. Finally, we take the letter T. ORD T gives us 84. So the word cat is represented by the codes 67, 65, 84. This shows how ORD can be used to convert each character in a string into its corresponding numerical code. Now, let's see how we can traverse a string step by step. Our string is cat. We start with index 0. At index 0, we have the character C. Using ORD, C becomes 67. Next, the index moves to 1. At index 1, we have AORD A gives us 65. Finally, the index moves to 2. At index 2, we have TORD T gives us 84. So the loop processes each character one at a time, from index 0 to index 2, and the final output is 67, 65, 84. This is called traversing a string using an index. Now let's try another example. This time we have the word dog. We want to display the numerical code for every character. First, we take the letter D. Using ORD D, we get 68. Next, we move to the letter O. ORD O gives us 79. Finally, we take the letter G. ORD G gives us 71. So the word DOG is converted into 68, 79, 71. The loop allows us to process each character one at a time and use ORD to find its numerical character code. Now let's move in the opposite direction. This time, we start with numerical codes and convert them back into text. We use the CHR function for this. Suppose our codes are 67, 65, and 84. CHR67 gives us C, CHR65 gives us A, and CHR84 gives us T. We start with an empty string. Then, we add each new character to the end of the string. First, we get C, then CA, and finally, cat. So remember, number, CHR, character, string. This is how we can build text, one character at a time. Now let's build a complete word from character codes. Our goal is to construct the word cat. We start with 3 numerical codes, 67, 65, and 84. Using the CHR function, 67 becomes C, 65 becomes A, and 84 becomes T. Next, we start with an empty string. We append C, and our string becomes C. Then we append A, and it becomes CA. Finally, we append T, and our completed string becomes cat. So we first convert the codes into characters using CHR, and then build the word, one character at a time. Now let's understand how to build a string step by step. We begin with an empty string. Then, we add one character at a time. This process is called appending. First, we append the character H. Our string becomes H. Next, we append the character I. Now the string becomes HI. Finally, we append the exclamation mark, and our completed string becomes hi. Remember, appending means adding a new character to the end of the existing string. This allows us to build a complete string, one character at a time. Now let's understand why input validation is important. When we work with character codes, we may want to accept letters only. In ASCII, uppercase letters use codes from 65 to 90. This represents A to Z. Lowercase letters use codes from 97 to 122. This represents A to Z. For example, the code 66 represents uppercase B, and the code 98 represents lowercase b. But a value such as 48 does not represent a letter. So before converting a code, our program can check whether it falls inside the allowed range. This is called validation. Validation helps our program accept only the data that the program expects. Now let's see how we can accept only letter codes. When a user enters a number, our program first checks whether that number is inside a valid letter range. If the code is between 65 and 90, we accept it as an uppercase letter. For example, 65 represents uppercase A. If the code is between 97 and 122, we accept it as a lowercase letter. For example, 98 represents lowercase b. But if the code is outside both of these ranges, we reject it, because it does not represent a letter. So the rule is simple: 65 to 90, accept. 97 to 122, accept. Anything outside these ranges, reject. This validation ensures that our program accepts only valid alphabetic character codes. Now let's understand why validation is important. A program should not accept every value without checking it first. For example, 65 is a valid letter code. Using CHR65, we get uppercase A, 72 gives us H, and 97 gives us lowercase a. These values are valid because they are inside the expected letter ranges. But what happens if the user enters 10 or 500? These values are not valid letter codes for this task. They could produce unexpected characters, incorrect results, or values outside the expected ASCII range. So remember, always validate the input before processing it. Good validation helps our program produce correct and reliable results. Now let's build a word using ASCII codes. We start with these 5 codes: 72, 69, 76, 76, 79. Using the CHR function, we convert each code into a character. 72 becomes H, 69 becomes E, 76 becomes L. The next 76 also becomes L, and 79 becomes O. Now we append these characters, one at a time. First, H, then E, then hell, next, hell, and finally, hello. So by using CHR and appending each character, we can build a complete word from its ASCII codes.